Access control, it can be registered in the design. Something like configuration register, I/O register, or memory map register that could give us ability to change the control or change the routing of the traffic. So next, we will define our track model. Here I show an example. So in this example, we have 5 entry points, entry point 0, entry point 1, 2, 3, and 4. And out of these 5 entry points, we have 3 places that can utilized by an attacker. The other 2 is not, maybe it's because they cannot act as a master, they do not have the ability to issue a cycle. And the other one we found out is where is the asset. So the asset will sit at the corner there. And the blue circle there is the access control. So the access control sometimes is spread over the design. It was implemented in many places. So we need to check all those. So with this track model, how do we put it in the simulation environment? So we have the validation model here. In the middle is the design under test, which we have the design inside, which is similar to the track model just now. You have the entry point 0 to 4, you have the asset, and had the access control. And then in the validation environment, we have a test bench, and they come together with a BFM tracker. So each of these BFM sit at the entry point of this model. BFM is help to issue the cycle or receive the cycle, and the tracker will be the observer and track all the transactions there. So with that, we can implement attacks and check. So for this model, it's easy to do the attack. We know that the attacker came from entry point 0, entry point 1, and entry point 4. So we do our test by issue cycle from BFM sit at entry point 0, 1, and 4. And we issue the cycle targeting the asset. And we write a check at the asset there and state that if the track agent accessing those data we want to protect, for example, encryption key, then it should give an alert message when our test hit this area. And if we're able to do that, we are done. However, there's not usually not very direct if we to do this, because the design sometimes does consider this situation. And so before we go that, let's look at the pen test and check. So when we want to do issue cycle, we need to write test. So there are many ways to write the test. There's many type of script can help you to do the test. Basically, I've talked about focus test and random test here. For focus test, you can write specific cycle targeting certain scenario, like the model just now. You can write a focus test, just write from the cycle issue from entry point 0 to the asset, and you can just run the test. And for random tests, you can use a test generator to generate the test. However, that does not guarantee that it do this type of testing for you. You can generate many tests, but you may not target your asset, or you may not even issue it from the track agent. So what we do on the random testing is we write coverage point. So coverage point is a guide for us to hit certain scenario. If not hit, then we can go back and generate the cycle again until we hit it. On the check, there are many ways to implement the check. The primary check for security testing, of course, is we want to make sure the test fails when the asset is under attack. We can implement other type of check in the model. This is to help us to test it more efficiently. Of course, we do not want to implement too many redundant check. So we will selectively implement the check at the place where potential attack can happen to the logic path that leads to the asset. And we can implement the check in many forms. One of the ways is we can use a post-processing script by collecting the data at the tracker. We can do RTL assertion. And we can also even do protocol checker. We can implement the check at the BFM. So this is one of the examples that we have when we do our pen testing. This is how we write the coverage point and check. We are crossing out all the signal name because this is top secret. Okay. Next is I'm going to talk about the obstacle in the design. Actually, it's an obstacle for the pen testing. It's a defenses in the design implemented. So when we do this type of testing, we just issue the cycle from entry point 0, 1, and 4, and then targeting the asset. It sounds easy, but the design will block it. Your test will never able to reach this area. So the other obstacle that we have is usually when we define a track model, we look at the whole system. In the whole system is usually very big. It's big for RTL model because that will make our simulation run very slow. If we want to put the whole system under simulation, we may need to run the test for many hours, and we wonder what's going on. And sometimes the machine may hang. So how do we overcome these two obstacles? Of course, there are other obstacles that we have, but here I'm going to share just two of them. So overcoming the obstacle. One of the ways to overcome the obstacle is to get a list of the register. For example, the configuration register, memory map I/O register, or I/O register. And then we need to ask ourselves a few questions. Normally, the entry point from the track agent are blocked. The design will block it because the architect and the designer, they are not stupid. They know these are the area that attacker can get access, so they will block it. So we need to ask if this is blocked, and but the register that associate with this track agent, are they locked too? Sometimes they may not lock, because they are certified that if the entry point is blocked, there's no need to block the register. But sometimes this register can influence the logic path that going to this asset. So we want to look at how we can utilize it. Can that influence the path, and we may able to get into the asset. And the next thing we want to look at is the debug feature. And most of the time, debug features are not available in the production. But again, for debug feature, design usually implement lots of register to enable it. There are multiple steps to enable a debug feature. So we want to look at those register. Although it is locked, whether we can get this register to influence the path that we want to analyze. The other thing is we want to make sure that the register we look at are able to write. From a user point of view, we can write it. If this is a read-only register, it will be meaningless for an attacker. The other thing that we want to look at is the design weaknesses. We want to get the list of design weaknesses. We want to know the motivation for the designer to implement the design in such a way. Sometimes they may design it due to cost, because they already have a design and they want to add in feature. They may not want to redo the whole design, so they find way that which is the easiest to implement the design. Sometimes in the way that they do this, they may sacrifice some security concern. So if we know the motivation behind it, then it helps us to make a better penetration testing. And we also want to look at some debug capability, whether we can use it as a backdoor. Of course, they don't design it as a backdoor, but we want to see that we can utilize it. And also, there in every generation of the product, we don't implement every product from scratch. So we add in feature on the existing design. So so this new feature added in, it may cause some existing protection to be broken. So we want to look at those. So in overcoming the obstacle one, we look at the access control. So there are multiple access control implemented here. There are access control that influence the path from the entry point 0, and also like at the entry point 1, and entry point 4, and also at the asset there. And you may have an access control which influence all the path. And also we consider the design weaknesses. For example, there is a path where entry point can issue a cycle going directly to entry point 0, but somehow they may implement a debug feature that can redirect the traffic. So if we change the access control and influence this debug feature, and this traffic may get redirected and get into the data that we want to protect. And when this happens, our assertion check should be able to flag it and tell us that the traffic already redirected. Of course, we can do this from each of the entry point that